Well, hello friends. Welcome back to the program. Today we're going to do some refactoring work, and it's going to be about Ipc services. So let me show you a typical Ipc service, the way we set it up. So let's look at config server, which is the configuration settings provider for applications. And what we do in a typical Ipc service is we create a core local server object, which is an abstraction over a Unix local domain socket server. And then we do this thing called takeover from system server, which means that we take the socket file descriptor that was actually created by the system server program and then passed to us. And then we could just kind of inherit that in this program. And then we set up an accept handler. So basically, the local server object will detect when there's an incoming connection. It will automatically accept that connection, and then it will invoke this onAccept hook handler right here. And this is kind of what most of our Ipc services do in their main.cpp. And then if you look inside of the accept handler, what we do is we just increment a client ID so that every new client gets his own ID. And then we call new client connection, passing in the specific type of client connection that we want to use in this program. So what I'm thinking here is that it's kind of silly that we do this in every Ipc service main file. So if you look at like launch server main, you will see some stuff specific to launch server, but then you have the same pattern here. So you're creating a local server object, taking over from system server, and then setting up an accept handler that increments a client ID and calls new client connection, and so on and so forth if you look at other services. So what I would like to do today is come up with some kind of abstraction where we can sort of encapsulate this whole thing into a simple pattern so that we don't have to do this everywhere, but we can instead just say, well, what would we say? I guess instead of creating a server, we would do something like, I mean, maybe we still want to call it server, but so we'll have some kind of convenience class in libipc, and something I didn't touch on is the fact that we have two types of Ipc services. We have multiple client servers and we have single client servers. And it's basically what it sounds like. Multiple client servers can handle multiple clients connecting to them, but single client servers only ever deal with a single client. And so single client servers are launched on demand. When somebody requests a connection, then we spawn a new process and let that process talk to that client only. So there's no multiplexing happening in those single client servers. But this here is an example of a multi-client server. So that's why we have an accept handler. And web content, I guess, would be a good example of a single client server. So in web content, there's no accept handler, but instead we just we say take over accepted socket from system server. So what that means is that system server has already got a ready-made accepted socket for us. And if you look at the way these services are actually run by system server, you'll see how that works. So the web content process sort of we set up this socket here. System server sets up this socket with these permissions, and then we say multi-instance true, and that means that whenever somebody connects to this socket, we will spawn a new instance of the web content program, and then allow it to take over this newly accepted socket, and that happens here. So that's sort of how a single client server is launched. And I think we can abstract this as well, although it's a little bit of a smaller savings because single client servers don't do as much setup. But let's start with the multi-client server. So I think we will call it multi-client server. Sounds like it's a bit of a mouthful, so let's just call it multi-server. And we're going to need the type of client connection because that's unique to the program. So we will say that we will serve this type of client connection. And maybe then we just create one of these things. And we should also make this fallible in case we don't have memory for this business. But I think something like that. Okay. And then how would that actually work? Let's just sketch it out here in the main CPP file. We don't have to edit headers just yet. This is just a tiny trick that I like to do in larger C++ projects. Like if you want to prototype some thing in a different namespace that would normally go in a header, you can save yourself a lot of rebuilds by just prototyping it in the CPP file. It's a simple trick, but it has saved me so many hours of waiting for compiles. So what does this thing actually do? So we have a type name, client connection type, I guess. And then we will need a static error or non-null own putter, let's say, to multi-server. Create. Okay. That seems kind of reasonable. And then what would it do? So it just has to do everything that we're doing here. What if we just yoink that in there? So first thing we need is a server. And since we don't have a stack here, we'll have to put it in a member variable. Ref putter core local server. So we'll say, oh shoot, wait. We don't have an object yet. This is a static factory function. So first thing we do is we just create this server on the stack. So core local server try create. And of course this can fail, so we have to wrap it in try. Also, let's just call this try for symmetry for now. And then after we set up the server, we want to take over from system server. So that'll be our next step. So we're going to try to do that. And then if that works out, all we need to do then is set up the accept handler. And so then we call new client connection with client connection type. All right. And I think then we don't need this to be a static int here, but rather we can turn this into a member. So we'll do something like this. And at this point, let's actually create the object. So new, no throw, multi-server, and then we'll pass in the server we just created. Yes. Okay. And I guess we can set up this lambda in the constructor. There we go. Yeah, so I'm still getting used to kind of these this new way of user space programming that we're learning in Serenity OS, where we actually try to handle errors. So now that we're writing something out here from scratch, let's take care to actually use try and make sure that we propagate any errors that happen immediately when they happen. So this looks pretty okay. Let's just use auto here just to be good boys. Yeah, this feels like it could work. So at that point, would this just work? Let's find out. So it built. That's a good sign. And let's see if launch server actually works. So we can test that by, I guess, like double clicking on something in the terminal, for example. So just double click on this README. And it opens the text editor. So launch server appears to have launched. That is fantastic. Okay, so all right, let's say that that's a good start. So let's move it to a separate header then. So libipc multiserver.h. Okay. Wait, how do I get there? Oh, okay. And then we need some headers. So we need error because we're using errors. We need libcore local server. And of course, this whole thing here has to be in line. We can't move it out to a CVP file because it is templated, right? So we end up putting it in a header file. I guess we could rearrange things a little bit and move some of it out of line, but I don't think that's such a big deal in this case. It's not a lot of code that we're talking about. If this were larger, or if it were to grow larger, we can think about reorganizing it so that some of it would go in the CPP file instead. But at this stage, it's like just a handful of lines. So okay, and then that C line is nice enough to tell us that local server.h is no longer used here. So that's a good thing. And what else do we need here? I guess we need IPC connection as well. Client connection .h. I think we need that one. That's where new client connection is, right? No, just connection.h. Does that still build? It does. Okay, cool. So let's try to apply the same pattern to other servers. libipc multi-server. All right, and then let's create the multi-server. So try IPC multi-server. In this case, it's a config server client connection. Try create. And then we can just That's pretty rad. I'm digging this. So let's see, let's nuke that thing. And where else do we have these? Take over from system server. Audio server. Oh, let's just do all of them. See what we can do here. So instead of config server, it's audio server, and multi-server. Tap, 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 tap. Oh, wait, back up. this guy was passing in something else to the client connection object. So here it's not as easy because we are passing additional state to client connection. Okay, so let's leave this one for later. Let's do the generalize, the simpler ones first, and then we'll come back to audio server. Okay, so forget about that one for now. Let's do clipboard. Clipboard is nice and easy. So again, we just need libipc multi-server. Multi-server clipboard client connection and try create. Tap, 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 tap. Cool. Okay. And, oh, lookup server. Interesting. That one, it looks a little bit different because we're not in main. We're actually in the lookup server object constructor. So this program is a bit old. It's not really written in the way I would write a new server. So I should probably refactor that at some point. And because like it's sort of an anti-pattern in Serenity to do fallible things in constructors because we have no way to propagate the errors. So what we want to do is we want to move all the fallible things outside of a constructor into either the function that calls the constructor or into a factory function. But let's just ignore that for now and see what we can do here. So does anybody else use this mlocal server for something? No, they do not. So that must mean that we can actually change the type of that to multi-server, and we will say that we do need to know the type of the client connection type here. So, oh wait, what was the client connection type? Just client connection. All right. Yeah, lookup server feels a little bit like outdated in the way that it's written. We have to give it a bit of TLC at some point. So what we'll do then is Ipc multi-server lookup server client connection. Is that not it? Is this thing not namespaced? It is namespaced. Lookup server client connection. And why don't you like that? Oh, I see. So I was using the lookup. I thought I was using lookup server namespace here, but I'm actually in the lookup server class within the lookup server namespace, and then lookup server here refers to the class, not the namespace that we're in. So this is an unfortunate state of things where we have a class with the same name as its containing namespace. But of course, the workaround here is just to omit the namespace since we are in that namespace anyway. Still, a little bit of an awkward contortion. So let's just call it mserver is, well, here we have to use must. So in situations where we cannot use try because we have no way to propagate errors, we do have a macro called must, which is a try. It's like try, but it just crashes the program if there's an error. So it's sort of a stopgap at this point that we'll use. And as you can see, it was used here already to do the socket takeover. Multi-server client connection, try create. that's a pretty nice change. Like all that stuff down to just a single line. Okay, and then take over from system server. Let's just find the other ones. So we have notification server. Let's do that one. This is pretty mechanical, but very enjoyable nonetheless. I really like this type of when you come up with a pattern to encapsulate something that you do repetitively in many places. It's just kind of satisfying to just sit down and actually come up with that pattern and then apply it everywhere. It never gets old, not to me at least. So here we'll just try to create a multi-server for notification server. Client connection. And we swallow all those lines. So nice. That is just nice. I wonder about this pledge here. We're pledging Unix. Thinking like, why do we need to pledge Unix? But it's probably, it's because we have to connect to the Windows server, because notification server actually connects to Windows server in order to display notification windows. And in order to establish that connection to Windows Server, we do need the Unix pledge promise, but we do drop it here after we have everything set up. So before we enter the main loop, we do drop Unix, which means that we cannot create any new connections, any new outgoing local socket connections, which is pretty cool. Okay. And who else? Sql Server. Ah, yes, Sql Server. I don't think I've ever, I haven't done any work on Sql Server. It's just all these other folks working on it. But we do have a growing SQL database server in Serenity, which is pretty cool subproject. Let's see, multi-server. Yeah, it's just a simple multi-server here as well. So good, man. These are just so satisfying. Okay. And then we have some other ones. So we have audio server. That one was a little bit weird. Inspector. It takes a path here, so that's new. Take over from system server, and it takes a path. What do we do with that path? Socket path. Okay, so if socket path is non-null. I guess if we have, if we've taken over multiple sockets, then we have to go and look in the set of overtaken sockets that we have. All right. So I guess we need to actually employ our multi-server thingy here with an ability to pass in a socket path. So socket path, and it's optional. So actually, let's write it in this way, because we've been moving towards using optional string anyway. So let's just take another step in that direction. And then here we can just pass on socket path value or like that. All right, and then that should allow us to, wait, where was it? SQL Server. No, Inspector Server. So here, that will allow us to use multi-server here as well. client connection, try create, and then the argument is temp portal inspector. All right. Cool. Yeah, and then Inspector Server is a bit special because it actually has two servers. So the second one is not managed in this kind of standard pattern way, so we'll just ignore that. And let's instead look at whoever is remaining. We have Windows Server. Okay, so there's Windows Server and audio servers left. All right, all right. What does Windows Server do? Windows Server sets up two local server objects. Sure. And then it sets up an onAccept handler in exactly the same way as these other things. So we could do the same thing for these. So let's do that. So here we'll say like, wait, what do we say exactly? I guess client connection and WM client connection. All right. And multi-server. This is going to be nice. So that's our standard client connection manager. And then we also have a window manager client connection manager. Okay, so we have those two boys. And then we just have to actually instantiate them. So I think we'll just do it here. Try create, passing in these paths, of course. So there's that one, and we'll wrap it in must since there's no propagation path here. This is also really old code that we need to give some love. But we can't do everything at once. So we will just do this thing right now. All right, so that gets rid of that. And we also get rid of these. Very, very nice. Nice and tidy. Could we drop anything more from here? I think the local server include we don't need anymore, right? Yeah. Yes. Okay, let's see if this works. What are we missing? Multiserver.h is missing new client connection. Wait, why? Sql Server main. Wait, what? Is not a member of IPC. Why is that? Oh, shoot. Wait, hold on. It's in client connection.h. I thought it was in connection.h for some reason. Yeah, there it is. I don't know why I thought that. I guess I was looking at this and then I looked at this thinking, oh, this is the file name of the current file, but that doesn't make any sense because it's an include statement. So yeah, that was the problem. All right. So let's see if the system runs with these changes. It does. Let's see some fire. Very cool. Yeah, so that's really sweet. I like this quite a lot. What kind of removal are we looking at here? We're looking at 23 insertions, 80 deletions. Of course, we do have a new header. So the new header, have to do that actually. Yeah, so 62 insertions, 80 deletions. So like net delta is not that large, but I still think it's a very nice change because it does simplify all of those main functions, and it makes it even easier to create a new multi-server if you want to. Why do we have a Windows Server connection include here? That's very suspicious. I feel like we don't need that. Yeah. Okay, so let's go for it. Oh, now I'm forgetting about audio server actually. So let's take a look at that again. So what the issue was. So the issue that we spotted here was that when audio server creates a new client connection object, we pass in the mixer. So the audio server's mixer object, we pass that into each new client connection. And I guess it's right here. Yeah. So I wonder what we should do about that. So the first thing that I notice here is that I don't think anybody else is creating a mixer, right? Yeah. So it's only ever constructed once in the main entry function. So we could also make it a singleton, for example, and then have a getter for it, and then we don't need to pass it here. Another option would be to make this more flexible so that you can you could provide construction arguments for your client connection somehow, but I guess the most straightforward thing to do at this point is to just ignore it, because I mean, we're certainly not going to change the way this works here in this commit at the very least, because that would be kind of violating the atomic purpose of this commit. So let's just do this one first. So libipc introduce add ipc multi server abstraction, let's say, or convenience class. This encapsulates what our multi-client IPC servers typically do on startup. Create a core local server, take over a socket, FD, a listening socket file descriptor from system server, set up an accept handler for incoming connections. IPC multi-server does all this for you. All you have to do is provide the type name. Provide the relevant client connection type. It's a template argument, template parameter. I guess it's a template argument in this case, because it's that instantiation. I never thought about that much actually, but I guess when you're instantiating a template, then you're passing template arguments. But when you're declaring a template, then you're specifying template parameters. Well, probably somebody's going to tell me I'm wrong in some subtle way now, but we can live with that. Still, that turned out pretty good. Yeah, so what do I feel about this? I guess I kind of feel like we can make the mixer a singleton. I'm tempted to just ignore it actually and think more about it. Did I miss any other ones? Doesn't look like it. Okay. And what about single server though? So here, for example, web content takes over an already accepted socket. Let's see, we have a couple of those, right? Oh, actually we have quite a few. So we have WebSocket, web content, request server, image decoder, and file system access server. They're all single server, single client servers. Should we come up with something for that? Would this be meaningfully, like, basically it's about these two lines here. Would they be meaningfully better if written this way? I guess what you don't actually need a single server object. Rather, you just want to accept a single client. So you have an already accepted socket coming your way. So we don't have to accept, we just have to wrap it in this thing right here. So take over accepted client or something like that from system server, web content client connection. Like you could do this. And I suppose it is nicer actually, because it does sort of encapsulate and hide the fact that you're creating this like local socket object and blah blah blah, and you don't have to care about that part, because like it is busy work at the end of the day, even if it's just a single line of busy work. And this does feel a bit more descriptive, so I do like it. Let's do it. And even though we don't have a single server object or class, I feel like it's still fine to call it single server.h, because it still kind of mirrors conceptually the multi-server concept, right? So like multi-servers include multi-server.h, single servers include single server.h. So and then what would it do? It would just have namespace, IPC, template type name, client connection type, and I guess we want to have an error or in this case. So error or non-null ref footer to client connection type, I guess. Something like that. And then, wait, does that thing take a string? It does take a string. Does anybody pass a string to that thing? Nobody passes a string to it, but it takes a string. So it has that functionality, but nobody uses it. Interesting. Well, let's just not take a string for now. And then if we end up needing to accept from somebody who has multiple takeover channels, then we can deal with that then. But for now, let's do it the easy way. So first thing we do is we just create a socket. And we do a takeover, and then we create a client and return it. So return client connection type, right? Yeah, so like that. And then we put that in single server.h. Okay, something like that. Is that everything we need? Wait, do we need local socket? Or does this thing bring that in? IPC connection brings in local socket. Yes, we're good. We're good. Okay. Yeah, that's actually kind of neato. Okay, and then we lose that include. It's actually pretty. This is actually kind of pretty in a way. Okay, so take over accepted. Oh, there's more of them. Yeah, here. Our language servers also use this type. Okay, so let's get rid of some of those and replace them with Sql Server. Try IPC, take over accepted client. CPP client connection. Look at that. That's rather nice. That is rather nice. We'll do the same thing for this guy right here. Okay. Okay. Yeah. Local server, we don't need that. Yeah, these are really nice. Just, I was skeptical at first, but like the more I see it now, the more I like it. Because it just, like now we just hide away the fact that you are creating a socket. Socket object. Like you don't need to look at that. It has no importance to you. What we really do care about is the fact that we create a client. Yeah. Delicious. Okay, well, here we're already doing the right thing. Yeah, just a couple more. Yep. And request server, finally. So client is try IPC take. Oh, we need to include it. Nice. And nice. Okay, will everything just work? Ooh, we have trouble. Okay. I probably got a little carried away. I forgot to wrap things in a non-null ref footer, I think. Or did I? Wait, what did I do wrong? Let's try to build that again. Okay, so what are you telling me? We cannot create a client connection passing in a socket like that. File system access server client connection. Why not? What do you want? You want a socket and a client ID. Sure. And what did I provide for you? Oh, I need to also provide a client ID. So the client ID is meaningless in a single client server or a single server because it only ever has one client. So it's kind of silly that we have to have a number at all. This is just the IPC system assigns a client ID to every client connection. So we just use one for single servers. And I think that's okay. Okay, now what more don't you like? Wait, what's the problem here? We are in image decoder. Image decoder main. Image decoder client connection. Wait, so this thing was not taking. This thing was not taking an ID. Actually, yeah, why do I have to pass the ID? That's still stupid. Because these client connections can just hide that detail internally. So this guy right here, he shouldn't have to care about this. Yeah, that should be handled internally by the client connection subclass. So this guy right here shouldn't be taking a client ID because there's only ever one client anyway, since it's a single server. So we'll just drop that right there. Pass 1. And yeah, and then this thing is written in a way, it has a hash map of client connections, but it's a single server. So it only ever has one client connection anyway, and we should get rid of that map. But that's outside of the scope of what we're doing right now. So let's just ignore it. And probably the same, we're going to see the same problem here in shell client connection. Yeah, it takes a client ID as well. So do that. You don't need a client ID, my little friend. It's okay, you can just pass uno. Yeah. Also the C++ language server, of course. We have to fix that one as well. No big deal. Request server. Okay, so it seems like this like silliness was actually in quite a few places. Request server client connection, also take a client ID. There we go. We should also fix that up. Okay, even more. All right. No big deal. All right, will this be the last one? Yes. Let's give it a whirl. Everything comes up. Let's go to the online web in cyberspace. And it seems like everything is working handy dandy. So kick ass. Let's make a commit out of this. So what kind of delta are we looking at here? Very humble, 38 insertions, 45 deletions, which makes sense. Not a very big change, but a slight gain in expressiveness. I still definitely believe. I think it turned out pretty good. So let's commit that. Yeah, so this can be, this is an abstraction or encapsulation of the common work done by all of our single client IPC servers on startup. Take over a core, create a core local socket, take over taking over accepted file descriptor. Let's just say FD. Everybody knows FD. Come on. Create an application specific, or a service specific. No, application specific. Client connection object. Wrapping the socket. Yeah, it's not a huge change in terms of lines saved, but I do feel that it improves expressiveness. Cool. All right, so I think these turned out pretty good. And yeah, I'm gonna keep ignoring the audio server one. We'll just ignore that because I don't know what I feel about passing the mixer in yet. Should we make it a singleton, or should we have a mechanism to pass custom arguments to client connection subclass constructors? I don't know what I like better, so I will have to meditate on that one. But in terms of where we started, like config server and launch server and those guys, I think this turned out really, really sweet. A single line, everything you now need to set up a multiplexing, multi-client IPC server. Very, very handy. So I think this will be the end of today's video. This was a heavy refactoring video, and I am very pleased with the outcome. If anybody has suggestions for how we can improve this further, then I'm, of course, very interested. So please let me know. Other than that, I hope that you saw something interesting today. And thank you very much for hanging out. I'll see you all next time. Bye.